the final talk by Athena. So you will talk about future plan, ESA and NASA. Thank you very much. So you know the time, you know when is the lunch, so you know what you have to do.
Yeah, no pressure, but I realized that I didn't get a chance to give my own personal perspective at this meeting at all. So if you'll allow me 5 to 10 minutes before your lunch, I just wanted to say that I'll go into this personal perspective. But first of all, it's great that we had an opportunity to hear from Carol and Jorn about the ESA program and all the wonderful missions that are planned from the NASA side. I wanted to say that I'm very much in favor always of international collaboration and synergies between missions, but I did want to say that I don't know if you've noticed, but besides the ESA program that was very well explained to you, the Voyage 2050 in the future and so on, the National Academy of Sciences in the US has built the Decadal Survey, which is also something that projects into the future. And all of these things have come together, and it's wonderful to see that they all came to the same conclusion, which is that there are a couple of things that we really want to do in the solar system and we haven't done so far, which are the icy moons, of course, and Enceladus came up in both of these programs. Enceladus is L4 for ESA, but it was also the second flagship that was actually put forward and recommended by the National Academy of Sciences Decadal Survey. And at the same time, I do want to say that it was also made very clear that we do need to get to the outer solar system and visit Uranus and Neptune, because these are places that we really haven't explored so far, and we really want to go back there. So you heard about the Voyage 2050. I just wanted to say that the Voyage 2050 plan also had a mention about Uranus and Neptune in there. Even though it didn't find its way to the final selection, we're still hoping that both agencies will at some time, and other agencies, come together and build something like that. So the NASA Planetary and Astrobiology Decadal Survey was something that happened and completed its work in 2022. And many people sitting here in this room were part of either the steering committee or the groups that were in there and were chaired by people like Jonathan and others within that decadal survey, which had identified, as I said, a number of scientific topics and scopes, from the origins to worlds and processes, life and habitability, and all of this finally came to the recommendation about the Uranus orbiter and probe as the first flagship. And I'm going to pretend that everything is nice and bright these days, and that everything is going to happen the way it was planned, because I'm not going to go into any of the geopolitical hustle, but I'm going to say that so then we have this opportunity to go and visit Uranus, one of the ice giants in the future. And also, we were very, very naive in thinking that we could also put together an aspirational budget and program, which included a second flagship and a number of other things, including making a very strong recommendation for Mars sample return that I will not go into detail here. But I did want to say that Enceladus Orbilander is out there, and I'm hoping that one day the two agencies will perhaps come together, perhaps an ESA-led mission to Enceladus, a NASA-led mission to Uranus, and then complementing and participating from all kinds of different international sites. The Decadal Survey also put together New Frontiers mission themes. You can see here a whole list of things. I just picked out 3 of them. There was a Titan orbiter, and I know that Dragonfly is going to take advantage of the fact that they're going in a season, at a time, at a location where they have the context from Cassini. But a Titan orbiter would always be nice to have. Another theme was this Enceladus multiple flyby. If we don't make it as a flagship mission, it's still worthwhile going and making a lot of flybys around Enceladus sometime in the future, and that was also studied. And there's also Saturn probe, because if you go all the way out to that system, people shouldn't think that we know everything about the giant planet. So these things are in there, and there was an expression in the decadal survey that there is need for coordinated exploration strategies. And I think it's very important to note that indeed, if you look at both ESA's Voyage 2050 and the decadal survey, not only the themes come together, but also if you look at the timelines, there is also a conjunction among the timelines for the launches that we've seen before. So hopefully all of that at some point will indeed proceed in the way we think it should. So I'm going to go take another 5 minutes and tell you that some of my personal perception. I was lucky enough to meet Carl Sagan after having seen him on TV for years, the Cosmos series and stuff like that. And I want to say that Carl was a wonderful scientist, but he was also an excellent communicator, which today is much more appreciated at the time. And Carl really inspired me, and I have this anecdote at a DPS meeting where I was going down, and I think he was coming up, and the elevator opened up, and he said, "Athena, good talk." And I think I stood there in front of the elevator for another hour or so before I managed to hit the button again and go down. But I did want to mention a lot of people that I had the pleasure to work with. Voyager was a wonderful mission too. I don't think we paid enough credit to Voyager here, and Voyager was actually 1 year, one Titan year before Cassini, and Dragonfly is going to get there another Titan year after Cassini. So we're going to get 2 Titan years in there. But Voyager was wonderful because I worked on the 300 Iris spectra that we had at the time. Daniel Gauthier came up to me and he said, "Here's 300 spectra. Do you want to work with them on an object that we really don't know much about, but here you are." And I did. And Virgil Kunde, Barney Conrath, Bob Samuelson, and Mike Glazer, whom we heard yesterday, helped me get into Titan business. There was also ground-based observations, and we started working with adaptive optics at ESA, but we also had a lot of observations from CFHT. I'm not mentioning my colleagues here. I just want to say the people that inspired me and put me in this business, and Michel Combe and Pierre Lénard are the ones behind the adaptive optics system. It started in our laboratory. At the time, it was DESPA, and Thérèse Ancrenas sitting there knows about how to run such a big space laboratory. At that time, there were very few women everywhere. I'm not going to show that picture where I'm the only one standing in the middle. But the two women that were in the lab at that time were Catherine de Berg and Thérèse Ancrenas. And Catherine shared her wonderful methane spectra with me for quite some time. And Thérèse helped me out a lot. And we also got observations from ISO that we didn't see very much in this meeting, but ISO was wonderful. Thanks to Thérèse's time, we got the detection of water vapor in Titan's atmosphere, benzene, and a lot of other of those components. And then in the end, I came on board Cassini-Huygens, and I remember being part of 4 proposals, and thinking, well, with any luck, I'm going to be getting 1 instrument at least. And I found myself with 3 of those instruments, probably because at that time I was one of the few persons who had worked on Titan and had a thesis on Titan. And so it was really a wonderful experience for me. I do want to highlight that we talked a lot about space. Ground-based observations are wonderful. I'm very happy we heard from people about ground-based observations. These are some of the older ones, the ones we got of Titan with adaptive optics, the ones that Peter Smith and Mark Clement got at that time with HST, and the detections we made at that time. And this is one of the first maps that I published in 2001. And I used to put the X where I thought Huygens was going to land. I think it was off a little bit in the end, but it was still a good map. I mean, it shows bright and dark regions, and that's all we have today also, in a way. So everybody has been showing pictures. I just want to show my picture of the launch. This is the whole lab at that time, hugging each other and being wonderfully happy. I only cry at weddings and launches, so I did cry that time. And this is the celebration for the 5th anniversary of Huygens in Barcelona, Spain. I don't know how many of you were there at that time, but it was a great, we had a bigger mock-up than this one, and that's with Bob Mitchell and Jean-Pierre Le Breton. Jean-Pierre has been wonderful throughout. I used to call him up and say, I know what Titan looks like. It's got silicates. I know what Titan looks like. And he'd put up with me. But all of these people in the Huygens experiment were wonderful. I know we lost a couple, and I'm very sad, but everybody else made a huge effort to come here. And Marcello put me on HASI at that time. Marty Tomasco got us into DSR, and like I said, Mike Flaser yesterday with the Sears instrument, because I had some experience with IRIS, was wonderful. And these are the photos that I have from sitting there in Darmstadt at ESA. And I don't know if John is still here, but one thing I remember, John Zarnecki, is him and I standing outside because BBC wanted to get an interview, and it was freezing cold and we had gloves on, and BBC said, oh, those gloves don't look so well, can you take them off now just for the interview? And we froze to death. It was really terrible. I don't think we've talked enough about Dennis Madsen. Dennis Madsen was wonderful. He led the mission beautifully, and even though he slept through most of the meetings here in Europe as soon as he came, he still led us through, you know, the whole complexity of that mission. So just to finish, I do want to mention a couple of things that happened since then. A lot of Titan mission concepts. A lot of people here in this room, Christophe Sautin, you know, Jonathan Lunin, a lot of people put together ideas about how to proceed. You can see some of them here, and we did also commit a couple of mission concepts at the time. The Kronos mission with Bernard Marty, Tristan Guillot and others, and the Super Titan tandem mission, which I came up for the acronym one evening thinking, oh my God, I don't know what to call this thing. And then I was writing Titan and Enceladus mission, and it came as tandem. And Sylvain Knud, who made the beautiful posters that you see here, he did all these posters also for those two missions that were wonderful. And Ralph mentioned actually the helicopter from his side. We had also proposed at that time, the Titan Explorer in tandem, we're proposing the balloon. And we had expertise in France from Jacques Blamont. Jacques Blamont would have put a balloon everywhere. He would have put actually several balloons everywhere. And he was very excited with the prospect of putting a balloon on Titan that he wanted to make into a hairy balloon, he said, in order to avoid any environmental disasters. But he did help us out with the TSSM mission, the Titan Saturn System mission, which took place, the study took place over 2 years, 2008, 2009. We also had different depictions of this. You can see a very pretty one also here. Everybody was very excited with this balloon. It came up in many magazines. And it was really a beautiful concept, which I like to think did inspire some of the missions that came afterwards. And it was a wonderful collaboration, international collaboration. And I did ask Carol before what she thought about international collaboration. because I was part of a committee, again, from the National Academy of Sciences that looked at cooperation benefits. So I think we all understand the benefits, you know, coordination for mission definition, for instruments, for observations, launch capabilities, the cost also sometimes. But people also look at international collaboration barriers, and those are real too. If you have a partner, the mission selection processes may not be synchronous. Securing commitment is also an issue sometimes. Proprietary data, the development of processes, security and sharing resources, ITER, and things like that always come in, not to mention international politics at some point. And there are failures. You know, I mean, you start an international collaboration, something happens along the road, and you have to make do with some of the failures, and I've identified a couple of this here, but the good news is Europa Jupiter system mission. It separated in two, and like I said before, we still have Europa Clipper and JUICE getting there at the same time, fortunately. So, so there's hope, and there are things we can do to improve international collaboration, I think. There are things to bear in mind with separating what the contributions are from everybody, and coming in early enough that we can dispel some of the things that could go wrong. So I'd like to finish again with Carl Sagan. This is a cartoon. I don't know that Carl ever said billions and billions and billions, but if he did, good for him. But he was thinking ahead in times of alien life, and what is toxic for us, like ammonia, can be water somewhere else in the solar system, and an alien coming down to Earth would say, please give me some ammonia so I can survive. But Carl was an inspiration to many people. And so ending, I'd like to, again, take an opportunity to thank the SOC here, the LOC, our sponsors, and ask you to join me for a drink. Thanks so much.